As we start a new chapter on radical functions, we have to start with a step back on exponentials. You probably already realize that radical functions and exponential functions are intimately related because you know that squaring and taking the square root are inverse operations. So in order to get to radicals, we have to go by way of exponentials. And sometimes it's easy to forget some of the most basic rules of dealing with exponential expressions, so let's take it a step back. For example, if we're multiplying x squared times x cubed, we don't end up multiplying the exponents. X squared means x times x, so you're multiplying x times x by x by x by x, which means you're multiplying x by itself 5 times. So the product rule tells us to multiply bases, you actually end up adding the exponents. What about the quotient rule? If you're dividing x to the 8th by x to the 5th, well, you've got a whole bunch of x over x, which all reduce to 1. So you end up with only 3 x's remaining. So this is x cubed. So the quotient rule tells us to divide the same base. You end up subtracting the exponents. This is called the power rule because we have x cubed to the power 4, which means we're multiplying x cubed by itself 4 times. And when we apply the product rule, we know that we can just add the exponents because, of course, this means you're multiplying sets of 3 of x's, really. So this is x to the 12th. Well, what about x to the 0? That is far less intuitive, I think. So let's use some numerical examples. For example, we know that 2 cubed is 8 and 2 squared is 4 and 2 to the first power is 2. Well, I can see that when I decrease the exponent, the result is basically I'm dividing by 2 each time. So if I keep this pattern up, 2 to the 0 is 2 divided by 2, which is 1. And if I keep this pattern up even further, I can see what happens when I'm dealing with negative exponents. If I keep dividing by 2, I have 1/2, 1/4, 1/8. Oh, interesting. This is actually the same, I've noticed, as 1 over 2 to the first, 1 over 2 squared, and 1 over 2 cubed. So with negative exponents, 2 to any power, let's call it m, would be, if that power is negative, you can just put 2 to the m in the denominator to make the exponent positive, right? Fill in a 1 in the numerator. Let's make sure this wasn't only working with 2's. Let's try it just with one other number, another base, to make sure indeed this is a pattern and not just an interesting coincidence. 3 cubed is 27, 3 squared is 9, 3 to the first is 3. This time the pattern is divide by 3. Oh, interesting. So in both cases, anything to the 0 power is actually 1. 2 to the 0 power, 3 to the 0 power, 84 to the 0th power. And let's take a look further at these negative exponents. If we keep dividing by 3, we get a third, and then a ninth, and then 1/27th. So yes, indeed, 3 to the negative 3 is the same thing as 1 over 3 cubed, in the same way that 3 to the negative 2 is the same thing as 1 over 3 squared. Okay, now that we have the basics intact, let's simplify some more complicated looking expressions. You may be wondering to yourself, where do we even begin with this sort of nasty thing? Well, we're going to use PEMDAS, as always, to tell us, what do we do first? Well, parentheses. There's nothing I can do inside of the parentheses per se, but I can see that this term is being cubed, so let's start by applying the power rule. And so I'm going to put this negative sign up top. I've got negative 2v times negative 2v all over v u to the 4th times y to the negative 6th v to the 0 power. Power rule tells me to multiply the exponents when I have exponents to a power. Okay, well, I did the parentheses and their exponents. Now it's time to multiply. Okay, up top I've got negative 2 times negative 2 gives me 4v squared over, in the denominator we have v u to the 4th, y to the negative 6th, and anything to the 0 power is 1. So we can turn this v to the 0th power into just a 1. Now, we notice that to make a negative exponent positive, we can just move it. So let's actually move this entire term. We'll have v4 squared y to the now positive 6th, since I moved it from the denominator up to the numerator. And then in the denominator, I have vu to the 4th times 1, which is just vu to the 4th. All right, I finished multiplying. I've made all of my exponents positive. Now let's divide. I've got 4, 2 v's up top, 1 in the denominator, so that'll end up with just 1 v in the numerator. And then I've got y to the 6th over u to the 4th. Okay, now let's take a look. Let me just double check my notes. Okay. Let's take a look at our next example. Okay, again, we're going to follow PEMDAS so we can decide what's the first thing we should do and the next and so on. So P parentheses, well, this time I can simplify what's inside the parentheses. A to the 0 power is 1 times b to the negative 4. I'm going to move this term to the denominator so that its exponent becomes positive. Times 2 times another a to the 0 is another 1. Okay, now I've got 2 in the denominator. That'll stay there. B to the negative 1 needs to move up to the numerator, so its exponent becomes positive 1. Okay, let's keep simplifying what we have in the parentheses. Up top, I have 1 times 2 times 1 gives me 2b over 2b to the 4th. All of this is to the negative 3rd. Now, parentheses, we can still simplify. 2 over 2 reduces to 1. So we have b over b to the 4th, all to the negative 3rd. That means 1b will cancel out. 3 b's remain in the denominator. And now there's nothing left to simplify inside the parentheses. So now let's deal with this exponent. This means I have 1 to the power negative 3 over b to the power negative 9. To make these exponents positive, let's move them. So we have b to the 9th over 1 cubed, which is just b to the 9th over 1. Or even simpler, b to the 9th. Okay, last one today. Again, we're going to follow PEMDAS to guide our thinking, so we know what to do first and what to do after that. Parentheses, nothing to do inside the parentheses per se, but I've got an exponent outside the parentheses. So reduce to lowest terms is a different way of saying simplify. So that's what we will do. Let's deal with what's outside of the parentheses first. So we have 2 to the negative 2. Don't forget that the coefficient 2 is also to the power negative 2. Y to the negative 2, x to the negative 6, all over negative 2y squared times 2y cubed. Okay, we've dealt with that set of parentheses. Now let's deal with the exponents. Anything with a negative exponent is getting moved so that its exponent becomes positive. Ooh, nothing left up top, so we'll fill in with a 1 over 2 squared, y squared, x to the 6th, times what we originally had in the denominator. That didn't move because their exponents were not negative. So we have 1 over. Okay, well, let's multiply these coefficients. 2 squared is 4. 4 times negative 2 would be negative 8. Times 2 again would give me 16. Oops, negative 16. Okay, I've got x to the 6th. I'm putting my variables in alphabetical order. Then I've got y squared times y cubed. That would give me y to the 7th. And there's nothing else to do here. So we are done. We've reduced it to lowest terms by fully simplifying the expression.